Galaxies are a big problem for the Big Bang right now. And that's what we're talking about tonight. This is my brother Nathan, and he believes in the old Earth and old universe, Big Bang, evolution, all that stuff. And I'm a young Earth creationist. I think evolution is false. I think the Big Bang is on fumes. It's not going to last much longer. It doesn't have a hope or a prayer. And I'm going to give you one of many reasons that'll help you see how wrong the Big Bang is tonight. So, Nathan, do you want to say anything?
Well, I'm interested in this, well, whatever you're going to throw at me. Um, I do think, science progresses, and people used to believe in a steady state model, and in terms of like, oh, there's like whatever, a static universe. Didn't believe in the Big Bang at all. Um, and then somebody, put forward this idea, and evidence started accruing that showed that it was true. So I think scientists are actually interested in breaking their models right now, like the standard model and things like that, because they know that there are phenomena that are unexplained. So I think that, whatever evidence you're throwing at me about holes in the Big Bang, scientists are probably actually very excited about it, because it gives them a way to research and explore new things, new ideas, and come up with or modify their hypotheses and this and that to explain the physical world around us. So I'm interested in what you have to say.
Cool. Well, I do want to disagree with you on this point because although I think they're eager to have little things to pick at and learn about, they do not want an overturned model because what does this mean? It means people who have built their entire careers on this idea of the Big Bang, people who have spent their lives researching this, the experts in the field, for them to be wrong and all of their work to be wrong, all their Nobel Prizes and everything that they've gotten to be just bunk is something that most people are not going to accept, right? They do not want that.
Well,
And
I
so,
mean, I mean, the cosmic background radiation, that's not going anywhere. So whatever new, fantastic evidence you have, first of all, one question is, does it support young Earth creationism? Probably not, but we'll see. And the other thing is,
okay, go ahead.
the other thing is, it's like, is it going to completely overturn, or is it going to be something like a revolution in the way that we view galaxy creation, formation? Um, that's more likely than to say, oh, okay, well, suddenly relativity is completely wrong, you know. Or the standard model is completely wrong. Well, no, I mean, we have
Wait, hold
confirmations
on.
over and over again.
Relativity is irrelevant in this. Relativity can be true
Oh,
and the
good.
Big Bang can be false. Okay? That's
Yes, of
irrelevant.
course.
Okay.
Well,
Now,
actually, I
with
don't know
regard
if
to
that's true,
cosmic
but
microwave background, what do you think that actually, what do you, why do you see that as good evidence for the Big Bang?
well, when the model was proposed, and again, I mean, just to make clear how our things work, once you give me a topic, I'm not allowed to research it. So I'm having to go off of what I remember. Now, I think I know a lot about the Big Bang. I think I can have an intelligent conversation. But if there are people on the channel who are experts, and you hear me say something wrong, or you want to add to my argument, feel free, because I'm not
Okay.
a expert, but I think I
Well,
know a lot. And I
okay.
think that
Well,
the cosmic background radiation, real quick, cosmic background radiation was hypothesized as something that would show up if the Big Bang model was true, because there would be relic light, relic energy that would occur and that this would come at the moment where space light could travel freely through space. So this was when ionized hydrogen became, neutral hydrogen or whatever. Um, it became unexcited enough, cooled enough so that light could travel freely. And they had this radiation was found by some guys, I think in New Jersey, making a telescope, and they couldn't figure out how they kept having this background buzz. And it turned out that they were actually, after they ruled everything out, they were listening to the cosmos and had found this relic energy from the Big Bang.
Well, that's an interpretation of it. And by the way, it was not what they predicted to find. They predicted it was an order of magnitude off of what they predicted to find. There's lots of problems with CMB, but that's not our topic for tonight. But just for the audience's benefit, there's two pieces of evidence that are supplied for the Big Bang. And every on the rhetoric is strong. If you just go looking, and even AI will tell you, oh, we have overwhelming evidence for the Big Bang, but when you dig into it, you'll find out it just comes down to two things: the cosmic microwave background, which can have a lot of other explanations, and there's good reasons to think it's not coming from the edge of the universe because of the axis of evil, which we can talk about another time. And the other evidence is redshift, which redshift is an absolutely real thing, but we have interpreted redshift and made it as part of the expanding universe. And part of what I'm going to talk to you about tonight is how that has been falsified through our observation of galaxies. The expanding universe, we've already done tests to show that this does not work with our observations. We actually knew it back with Hubble, but now with JWST, it's even worse, and that's what I'm going to talk about tonight. So are you ready, Nathan? Do you want to respond to any of that?
Let's just proceed. I think we
All
can
right.
jump down 1,000 different rabbit holes, and I'm
Okay.
sure young Earth creationists have some sort of explanation for all of them. So let's
Well,
just go. Let's just
actually,
move on.
you mentioned, will this support young Earth creation? And in a way it does. Not specifically this, but actually just the existence of spiral galaxies themselves. The existence of spiral galaxies is a good indicator that those galaxies are young, because in order for those galaxies to still have those spiral arms, it they shouldn't be as old as cosmologists say that they are. So in order to
And what
keep
about
those,
all those other galaxies that are full of red stars? I mean, or there's tons of evidence that stars have been evolving. We did do a talk on that. So
I know,
anyway,
and you
I think we
got
should
your
move on.
butt
Let's
kicked on that, Nathan. You absolutely got your butt kicked on that. So
Okay. Well, let's continue on.
all right, but
Moving on.
young Earth, spiral galaxies, the way that we are able
Am I
to
going to have
keep
some
this.
evidence? Is there going to be
Yes,
some evidence I'm
you
going to
are.
get to explain?
Right now, the way that we're keeping spiral galaxies together is with dark matter, a non-existent entity that has been made up in order to rescue the galaxy ages. But I'm going to go ahead and start my presentation. So the JWST, James Webb Space Telescope, has sent us back awesome images. This is just, I thought this one was cool, so I put it on here. But basically, we're seeing galaxies at redshifts that are farther than we ever have seen. And we did not even expect that we would see galaxies out that far. When this
By
information
out that
started,
far, you mean light years? Light years? You're talking light years, right? How far
yes,
away they are?
yeah,
Okay. So billions of light years away?
yeah. I mean, and of
Okay.
course, I don't agree with the light time travel so I don't believe that the light left those stars that long ago and the galaxies that long ago. But
And
that
and
is
just to make clear, you don't believe that the light was placed in like the appearance of age either.
no. I
You think
don't.
that those are actually we're receiving that light somehow much faster?
Yes.
Okay.
Okay, but that's
So
not the
so you
topic
are saying
today. You
you are
can
saying
challenge me on
relativity
that
is
if
not
you
true.
want. You've already challenged me on that before. I gave
Yeah.
you an answer that's
No,
in
no, no,
line with
no.
physics, and
Uh,
you didn't
No,
accept.
it was not in line with physics. You
Yes, it
you
was.
sent me something that when I watched it,
Okay,
no, when I watched it, you have someone, if I sent a radio, somebody on Mars was talking to me on Earth. If I sent a message back, they wouldn't receive it. They would miss it because somehow light was doing different things in different directions. So no, it did not answer the problems that you have with relativity, but we can move on.
yeah, we need to move on because we'll never get through this if we stick on that. Okay, challenge me on that later if you want. But this is what was said about these galaxies that we were seeing at the high redshifts. We've informally been calling these objects universe breakers. Now,
No, and this guy looks so happy. Why is he so happy? But he's saying that.
he
It's
took that
almost like he's
picture
happy
before
about it.
the information came. He
No,
took it
all
before.
right. Okay. See,
Okay.
they love this stuff. They like to break their models because it means there
Oh,
might be a
come
Nobel
on,
Prize for
Nathan.
them.
You're very idealistic, but no, it's not true. Look, and this is Eric Lerner. He is one of my scientific heroes because he has stood against the Big Bang for 30 years. And by the way, he's not a young earth creationist. He believes in evolution. He doesn't believe in God, so he's on the godless side, but it, look, he has been standing against the Big Bang for many years, and he says, guys, the universe is fine, but the Big Bang is dead. And so here's
Okay,
why.
and well, what does he say instead? It's interesting because you said okay. He
Yeah.
said the Big Bang is dead. What does he think?
Well, he actually believes that the universe is eternal.
Okay, so
So,
he's like a steady state person.
yes, basically.
Ah, okay, so we're going back to the 19th century. Okay, it's possible. I mean, let's let's go forward.
Okay. It's so funny to me, Nathan, that you actually think you're really standing on solid ground with the Big Bang. You think we're going back to the 19th century? Maybe we need to because right now cosmology is all fantasy. Okay,
Look, I have other ideas about the beginning. We could all be a hologram at the edge of a black hole. So maybe Big Bang is wrong. I mean, uh, it still doesn't change the fact that we have all of this evidence that needs to be explained if you're going to have a different theory. So if he has a steady state theory and he can account for all of the evidence, that's fine. That's still not young Earth creationism.
okay.
Ta-da.
Well, let me get my
Yeah.
point.
Points.
There's
Okay.
three
Sorry.
three problems with the galaxies. We're finding fully formed galaxies at high redshift. According to the Big Bang model, those are not supposed to be there. There's not even at the place where we're seeing galaxies, according to the Big Bang model, there weren't even stars at that point. Okay. So that's one problem. No, problem number two is the composition of the galaxies at high redshift. We're finding heavier elements than should be there according to the model. Problem three, density, mass, and surface brightness of those galaxies is not feasible with the expanding universe model. Okay.
Okay.
So,
Can I address these issues
sure.
one at a time? Okay. So fully formed galaxies at high redshift. So I do think that this is, a challenge to the current modeling of the universe. People thought that, you wouldn't have galaxies as big as they are, and that you wouldn't have galaxies as well formed as they are. I think they were thinking it was going to be at like 1 billion years or something like that. And I think right now what we're seeing is, if I couldn't research, so this is just coming off the top of my head. I think it's around 300 million or something like that, like years after the Big Bang. And so that is a challenge to our current explanations of um, uh, galaxy formation. And again, people are actually excited about this. They're not shaking in their pants or whatever about it. So compositions of galaxies at high redshift, this is also a challenge. People have thought in the past that it would take a long time to anything in cosmology, anything that's heavier than helium, I think is called a heavy element or a metal. And so you have higher metallicity in some of these things than we expect. I agree with that. So if that is a problem with our current models of galaxy formation. And then, so far, I guess I'm in agreement with you. Problem three, density, mass, and surface brightness not feasible for expanding universe model. Well, I don't know if I would agree with the not feasible with expanding universe model. So you'll have to explain that a little bit more. But in terms of the brightness of these things, one of the things that we have found is that some of these black holes are much bigger than we expect. And so people are having to think about black hole formation. And black holes, it turns out, are really important for how you form a galaxy and how a galaxy evolves. And so, there was people used to think that if you have a black hole, only a certain amount of matter can fall in at a certain time, because beyond that, the light, from all of the infalling matter and stuff getting heated up, would essentially create a back pressure that would keep it from growing after a certain rate. And I think one of the things that people are looking at is that if you have these high concentrations of gas, well, two things. Number one, you have what's called a direct collapse. So even though there might be this pressure going backwards, if you have extra matter falling in faster or compressing faster than that, then you might have black hole creation, these supermassive black holes, much faster than you thought. So that is one thing. The other thing, I was reading an article on this, is that a lot of our models of black hole creation did not take into account, I think mostly because of the problems of computing, all of the electromagnetic effects in terms of you know you have different forces. You have the force of gravity, obviously, which is the black hole pulling things in, and then you have charge. So you have, you know if I rub things together, I get static, that kind of thing. And so, now they're doing some modeling where they're trying to improve their models by incorporating that, and they're finding, some that these effects are dramatic around a black hole. So I think that we are improving our computer simulations of black holes, and we're also trying to find out more information about black holes by doing, like, imaging, quote unquote, black holes. Can't see the black hole itself, but what's happening around black holes. So, scientists are collecting more information about black holes, and this is an active area of study.
Okay. Well, I realize I kind of worded this weirdly on problem number three, but since you agree with problem one and two, we'll probably spend the bulk of our time on problem three. But just to go over it very quickly, the problem one, fully formed galaxies way before it's supposed to even be stars forming. This is a huge problem because there needs to be time for the the formation of these things, and it wasn't too long ago that you could still find online where it said it would take 7 to 8 billion years for spiral galaxies to form or for elliptical galaxies to form. And now we're finding spiral galaxies where there shouldn't be galaxies at all. Okay, so that's problem number one. You totally agree with that problem?
Yes, well, I would say that I think that we are looking at how um, galaxies form, and yes, it is surprising to scientists that you find spiral galaxies that close to, you know, that far in time, looking back in time.
Okay, not just surprising, it's a contradiction of the model. That's what I want to be clear about because I feel like with the Big Bang model and other uh, you know, models that are being pushed in academia, no matter what, they don't admit it's a contradiction of the model. They just say, "Oh, we're surprised. Hey, great. It's so great. Science is always changing. Science is always developing. We're already always learning new things." But really, we have to admit that this is a contradiction for the model, right? It doesn't by itself mean the model is totally wrong, but it should be admitted. Do you
Well,
admit that
it
this is
it,
a
it
contradiction of the model?
no, I mean, I don't. If you're saying, do I think this is a contradiction of the model, like the Big Bang model? No. Do I
So
think
wait,
that it's a
how does it not?
contradiction in a computer model of galaxy formation? Then I would say yes, it means that our modeling of galaxy formation is not correct.
Okay, so
It's
I'm not
not, it's
saying it's
not
a
accurate.
contradiction of the entire model. I'm saying that that part of the model is contradicted. The part about galaxy formation has been contradicted now.
Y- Well, I would say that yes, they need to figure out how you could have this happen, how you could have spiral galaxies, you know, this far back in time. Yeah, they
Right.
have to
And
try
the
and account for
model
that.
doesn't allow for it. In its current form, the model does not allow for this.
Well, I actually I don't know about that.
Okay.
But you know, what happens is you have people who have many models and they're trying to select for the right one. So, you know, in particle physics, for instance, you know, they know that there are certain things that are unexplained. So people come up with models. These are hypotheses about how they're going to, you know, modify or expand the standard model. And you know, so it's like theory crafting. What could be, and then they try and find ways to test those models, and those models get ruled out. So, for instance, you know, you're talking about scientists who have worked years and years and years. There are scientists who worked years and years and years on supersymmetry, but as far as we can tell, supersymmetry in particle physics is not correct, or it needs a major modification because they are winnowing down what models could actually have supersymmetry, and they've almost excluded all the parameter space. And the same is true with the Big Bang. People have models. People thought they had a good model for what happened after the Big Bang, right? Nobody's saying the cosmic background radiation is something else or blah blah blah. It, what they're saying is, look, there are processes that are happening that we don't know and can't explain, that we have this phenomena, and now we have to come up with new models and figure out ways to test them.
Okay, I'll take that as close as I'm going to get to an admission of a contradiction in the model.
Okay. All right.
I, all right, but okay, my little cartoon. You said I needed billions of years to form. Do your best with 200 million. Now, um, so the next problem is the unexpected heavy elements. And I'll just read this quote from one of the scientists that, you know, wrote in this journal. He said, the composite picture of galaxies contained eight identifiable elements: hydrogen, helium, nitrogen, oxygen, silicon, sulfur, argon, and nickel. While the lighter elements were expected, the presence of nickel, which is heavier than iron in the periodic table, came of somewhat as a surprise. Never in my wildest dreams did I imagine we would see nickel, Strom said. And I'm sure, Nathan, you can tell us why nickel is an especially huge problem.
Well, so if you have iron, you know, stars fuse elements together, and so there's a certain amount of energy released during that fusion process. As you get higher in the periodic table, the amount of energy that you get out goes down until you get to iron. After iron, it actually takes more energy than you get out to make these heavier elements. And so if you have an element like nickel that's past iron in the periodic table, that means that the star was not only not getting any iron out of, I mean, not getting any energy out of making that nickel. It was having to have so much excess energy to form the nickel. And so, in the past, we thought about heavy elements as well. We already knew there were problems with having supernovas generate these heavy elements in the abundances that they do. One of the things that's very interesting is, we have now seen that, with neutron star mergers and things like that, you have a geyser of these heavy elements get spit out because there's so much energy that's getting pumped into the surrounding space around these things, these gigantic monsters as they come together. And so this actually fits well with, I think, this is just the world according to Nathan, some of these models of direct collapse with black holes, because it means that you had these neutron stars, black holes, things like that earlier in time. And so if you had them coming together or in a dense cloud or whatever, or you had neutron stars or whatever, maybe you get these elements much earlier than you expect. Also,
Okay.
I
Do
also need to
you
point out one more
accept
thing.
this as, go ahead.
Um, uh, so scientists think that there was a class of stars, super huge stars, that were much bigger and much shorter lived than we have now. And so originally they thought that these massive stars were kind of what was the progenitor of some of these metals. And I'm not sure if that's tenable anymore or not. I don't know enough about it. But I would guess, this is just again theory, world according to Nathan, that we're going to find it's actually more of these heavy objects that are generating these heavy metals, or metals with all this extra energy needed.
Okay, well, you know, do you admit that this is a contradiction of the Big Bang model, which said that, first of all, there weren't even supposed to be galaxies there, but now the composition of the early universe is not supposed to have these heavy elements. So, do you admit this is a contradiction of the model?
Well, again, not I would say not the
Not of the
model
entire
of the
model.
big.
I'm saying of
Yes,
the of
yes,
what is proposed in
of
as
what,
part of
yeah.
the model.
Well, of what people thought before. Yeah, of course. I think this is a challenge to those models that people had come up with for galaxy formation. Yeah.
Okay. Okay. Then we can move on to the third problem, which I think is the most interesting, which is the problem that when we add in the expansion calculations, okay, for galaxies that are at a high redshift, okay, and just I made a little cartoon to make it simple, but we'll have to get a little bit technical. But my cartoon, with no Big Bang expansion, I'm just an average galaxy far, far away. If Big Bang expansion is true, I'm impossibly small and dense. And I just showed the little scientist wanting the galaxy to fit in a smaller dress. Okay. Now, so the point of this is, you like my cartoon? Okay. The point of this is that when we, okay, because of the expanding universe, and I had to like really watch and think about this for a long time to understand it. Maybe people will get it simply, hopefully they will. But because the universe is supposedly expanding, okay, when the light supposedly left these galaxies, they were actually closer to us than they are now because there's been all this time. So when we observe when we get the feedback from the JWST, we actually have to factor in, okay, the expand, like that it was closer to us. All right. And that makes the galaxy, so that actually makes the galaxies appear different than they would if the universe is not expanding. Okay. And it actually gives a weird thing where it makes them appear smaller than they actually are. because we're considering that they used to be closer, right? So like if you're looking out into the distance, as you look out into the distance, things actually get smaller. But if you were once closer to those things, then they would have been bigger at that time. So we have to calculate that in when we're doing for expansion. And when we do that, because so many scientists are convinced that the universe is expanding, I don't think it is, we end up with ridiculous galaxies. I don't know if you can see this because I know it might be kind of small, but I'm giving you the example of a galaxy that was recently found with the JWST at Z14, redshift 14, which is way out there. It's like supposedly 250 million years after the Big Bang. Okay. So this, I don't know if they call it MOM Z14, but it's MOM Z14, MOM Z14. Now look, can you see this, Nathan? Can you see the
I
diameter of this
mean,
galaxy?
148 parsecs.
148 parsecs. Okay. Yes. Okay. And then compare that to three galaxies that are pretty close to us. Okay. So not that don't need the factoring in of the expansion like we do with this. Okay. So because if they're closer to us, they don't need it. So look at the difference between the size of these galaxies. Okay, 67,000 parsecs across, 18 18,400 parsecs across, 9,800 parsecs across. Now there's a wide span of how big galaxies can be. Okay, and so Andromeda and some of the other ones, these are on the higher side. But I want you to look down at the next line that shows stellar mass density. So how dense are these stars? Look how bizarre this high redshift galaxy is. Okay, the stellar mass density is 60, even though it's way smaller than
Yeah,
these other galaxies. Look at the difference. So these other
yeah. All right.
galaxies, go ahead.
I'll let you finish this graph, and
Okay.
then I'll give my rebuttal.
Okay. So, and then look at the surface brightness. Okay. The surface brightness, and these numbers may seem small, but this actually, it's a huge difference. This galaxy is ridiculously bright. Okay. Compared to galaxies that we don't do the expansion calculations for. So look at this headline that came out June 5th. A cosmic miracle. A cosmic miracle. Okay. Or y'all have messed up. It is not a cosmic miracle. It's just a faraway galaxy that you messed up with your expansion calculations. A cosmic miracle, a remarkably luminous galaxy. Okay. At Z14. All right. So now I want to do one final comparison before
No,
you
can I?
go ahead.
Oh, okay.
So look again at this mom. Okay, so I put a little picture of it, the galaxy up there. And I tried to find a local galaxy. I asked AI to give me 10 like local galaxies that, were dwarf galaxies, so smaller galaxies. Okay. And I took the smallest one with the smallest diameter, which was Ursa Minor, dwarf galaxy. Okay. So it is 280 parsecs across. Now look at the difference between the stellar mass. This is like, now it's still larger in span than the one at redshift 14. But look at the difference in the stellar mass density.
Hmm.
Okay. Look at the difference in the surface brightness. So anyway, and I put this under, this is where the extreme nature of this Z14 galaxy becomes clear. Its stellar mass density is more than 2,300 times greater than that of Ursa Minor dwarf.
So let's
Go ahead.
rewind a little bit. Go back one. All right. So, yeah, I I mean, I think this is all very interesting. One question I would have is, are you sure that what we're seeing at 148 parsecs is not actually the active center of a galaxy? And you say, well, how is that possible? And the answer is that you have so much matter accreting around a gigantic growing black hole that it outshines the brightness of a modern galaxy. And I think that that actually makes sense if you have a bunch of now again, the models need to change, people need to account for these things. But if you start to account for things like the charge of all of these gas particles swirling around this thing, and they're finding out, they're modeling all kinds of things and figuring out all kinds of things about how you can get black holes to accrete faster. But it it makes sense with all the data. So I mean, this is, again, I'm just reading what you've got, and if we have any experts on here who want to correct me or modify what I'm saying, that's fine. But so what do you have? You have higher metallicity. So that requires something, a furnace that is generating these particles or these atoms that require a bunch of energy. You have we already knew that we have these supermassive black holes, and people are trying to figure out how did these supermassive black holes come about. And we were looking at for intermediate black holes, and we have found some intermediate black holes, but not enough, I don't think, to account for supermassive black holes. So we knew we had to account for supermassive black holes. And here you're looking at these very, very, very bright compact objects near the beginning, that are outshining, you know, everything. And as you showed, they have a super high density. If we look at the universe today, we find astounding things. We find black holes. I think I put up one in one of our previous talks that, or maybe I just looked at it, um, that the black hole is as heavy as like a galaxy. So you have a galaxy rotating around a black hole that's as heavy as a galaxy. I mean, it's there's things out there that are just crazy in terms of size. And so what would I expect to have happen? Well, I would expect that you have these large scale clusters now where we look at things and we see, you know, on a galactic scale, these kind of huge structures of galaxies that are gravitationally bound. And some of them, it's hard to account for all of the weight of those things. And it's hard to account for the weight inside of each galaxy because of these supermassive black holes. But if at the beginning you had these gigantic, gigantic processes happening, generating all of this energy, spitting out all of this stuff, then yeah, maybe galactic formation happened much faster, or maybe what we're looking at is not exactly a galaxy that we see today. It's a really hot furnace of direct collapsing gas turning into this gigantic furnace with these electromagnetic lines that are allowing things to get zipped in much faster than you would expect into this black hole, and it's just a monster. That's what I think we're seeing, but that's just my
Okay,
guess.
but I do believe that black holes at the beginning of the universe like that are also a problem for the model.
But let me say one more thing, because you're giving me some evidence. I was just reading so one of the problems in Big Bang cosmology was what's called the Hubble tension. And the Hubble tension was the difference between the expansion rate between the cosmic background radiation and the latter, looking at
Yes.
close stars, looking far away. And I was reading a paper recently where they are now able to start bringing those two things into alignment, that we
By
have better information about the stars, you know, the latter model that's bringing it um, in, into alignment with the cosmic background radiation. So I think that in terms of the Big Bang Theory, all of this extra information from Webb, and not just Webb, there's also, ground-based telescopes that are using um, you know, computer algorithms basically to correct the light that's passing through the atmosphere. That's also allowing us to use ground-based telescopes much better. Uh, and so yeah, it's causing problems, but James Webb, which people again like, they don't dislike that their models are getting disrupted. That's a possible Nobel Prize waiting in the wings for them, So they like that they're getting disrupted, and also some of these other things are we're finding out information that's bringing clarity where there
They
was a
like it
Hubble
as
tension.
long, go ahead.
Yeah,
They like it as long as it doesn't mean complete destruction of the model and everything they've worked for in their careers. But regarding, the fake crisis in cosmology, the made up one, which is the difference between the CMB and the ladder that we typically use, right? That's the one that's the distractor. That's the one so they can admit they have a problem in cosmology, but it's not like that big of a deal. Like, it's the distractor from all the real problems. Okay, it's one that they can talk about and make it titillating and stuff, but it doesn't actually involve the real problems with the Big Bang. And the CMB calculation, like, to me, that's like they it's all made up. So I'm not even, anyway. I'm but that can
okay,
be
well,
a
let me tell a different
different.
story.
Okay.
Let me tell a different story. When Einstein came up with relativity, he wanted the universe to be static.
Oh, I
And
know
so
this
he
story.
Yeah,
I
and
know
so
this story. Let's save
and
this
and
story for another night, because that's
and,
a that's go ahead.
well, let me just very quickly, we can
All right,
expand on that
because
in
I
the
have a
future.
lot more to
Okay,
say about this galaxy thing. So
yeah,
go
I'm
on.
sure you do.
Go
I'm
ahead.
sure you do. Okay, so he didn't want the universe to expand, so he created his major mistake, whatever he said, and added this thing to try and keep the universe together. But it turns out that the universe was expanding. And then everybody thought, okay, the universe is expanding, but eventually it's going to slow down or whatever. And then they found out, oh my gosh, it's expanding, and it's expanding at an increasing rate, and that didn't fit their models, right? So now we have dark energy and dark matter, which we have no idea what those things are, right?
Yeah, because they're
Um,
made up entities, Nathan. You know why? Let me tell you why we came up with the idea that there's an accelerating expansion. And by the way, we have not discovered that the universe is expanding. Okay, that is an interpretation of the redshift that has been pushed for a long time. And if I ever get to the rest of my presentation here, I'm going to show you one way that the expanding model is contradicted. Okay, but if since you're bringing up all this, since you had to tell your
Well,
story.
no, what my story, the point of my story is that scientists are constantly finding out things about the universe that are inconvenient for their established models.
Okay,
And
then
they
let's
like
drop it.
that.
Then
I
let's
mean, they
drop
hate
that.
it and they like it.
Okay, well, we have a fundamental disagreement about that. We can agree to disagree, because that's not what the debate's about. But since you brought up the cosmological constant, the Einstein's biggest blunder, guess what? Guess who got it out of the garbage can? Adam Rees, when he, discovered dark energy. Okay, he got it out of the garbage can, but it should have stayed in the garbage can. Okay, because why did Adam Rees get those calculations? It's in his Nobel speech. Why? Because when he did his supernova calculations and he calculated for expansion, he got a negative mass for the universe. Okay. Now, instead of saying, hey, we got a negative mass, this cannot be right. Maybe we should question this whole expansion thing. Instead of questioning expansion, we made up an invisible force that we have no idea where it comes from to balance out so that the universe doesn't have a negative mass. That is how dark energy was born, folks. And it is a made up thing. And it is it's making, this is all a mockery of science. Okay. Why don't you get a brain in your head? Not you, Nathan, but I'm saying, like, why don't these people ever, why are they so beholden to the model that when we get a negative mass for the universe, you don't say, wait a minute, this can't be right. Something is wrong with my calculations. Not something is wrong and we need to make up a new entity in the universe that we have no detection of.
Well, I mean, I think what you're saying, um, when people say dark energy, what are they saying? They are saying we have a phenomenon and we don't understand it. Um, and so you're free to come up with any hypothesis you want about that. And what will happen is that if it's serious enough, if people take it seriously, they may try to come up with a way to either prove or disprove your hypothesis. That's how science works. So, we had all this information. We're getting more information about these expansion rates all the time. That's how the Hubble tension is now going away because people said we need better information about the stars in order to make sure that our ladder model is correct. And so now we're able to see supernovas further and further away, and that improves the model, and we're able to see how the precision of our measurements of stars are going up, so we can figure that out. But yeah, you're right. Maybe we find out that dark energy and dark matter are really the result of something completely different. I don't think we're going to find out that what that really means is that God created the universe 4,400 years ago or whatever.
Well,
So,
longer than that.
maybe the Big Bang is completely wrong. I don't think so. There's some aspects of it that might be wrong. But I'm open. I'm open to it being completely wrong.
Yeah.
Like I said, I have a cockamamie theory about being a hologram in a much bigger universe. But, you know, we would have to come up with data to either support or disprove that hypothesis.
And
And right now, it's
Nathan,
just my cockamamie theory.
okay,
But
and I'm going to tell you the
but let's
last
say that we find out Big Bang is wrong, it's a steady state model or something, or it's a black hole or whatever the universe is, it's a hologram, whatever it is. I don't think we're going to say, oh, suddenly, actually, it was all just created 4,400 years ago.
lie. Why do you keep saying 4,400 years ago?
Well, whatever the young Earth
Okay,
timeline
less
is.
than 10,000 years ago.
Less than 2,000
Okay,
years. Less than
10,000,
2,000 years.
but more than 4,400. Okay.
Okay.
Now,
I'm sorry. Between 4,400 and 10,000.
no,
Okay.
not between 4,400. We have recorded history at 4,400. Okay.
Yes.
So, no. All right. But I've noticed that when people, anyway, no, I'm not going to go there. Look,
No, because but you're not espousing your own model. You're just poking holes in trying to poke
and
holes,
that's
which is fine.
perfectly legit. No, it
It
is.
is.
It's perfectly legitimate for me to say this model is wrong and here's the evidence. And by the way, this isn't just me saying it. There have been very good physicists who have pointed out that this is very problematic to the point that we need to get rid of the Big Bang model. But guess what? They get silenced, they get canceled. Okay. And they do put forward proposals. And I'm going to give you I'm going to give you some evidence from someone who has been part of that right now.
Okay.
So,
I'm all
okay.
ears.
Okay. So, and this is, and by the way, let me just give this. This is from a publication, a journal called Galaxies. Okay. And so they did cosmological model tests with the JWST. This was their findings. There's an excessively large number of galaxies at very high redshifts, which is not foreseen by the standard cosmological model. Galaxies at these redshifts have disk bulge, which indicates they have passed through a long period of evolution. Spectroscopically, these galaxies resemble their counterparts in the local universe, meaning we shouldn't be calculating them as ridiculously small and dense because they actually, if you don't put in the expansion calculations, spectroscopically, they actually look like local galaxies. Smaller galaxies are more massive than larger ones, which is quite the opposite of the common view. Now, so these issues indicate that galaxies at redshift Z greater than 14 discovered by the JWST do not have enough time within the framework of the cosmological model to evolve into what is observed. Their finding, we conclude that these observations cannot be explained by the expanding universe model. Okay, this is the prediction of the Big Bang model. If you look at the dotted line across the top, like the dotted line that curves around, that's the Big Bang turnaround that I said. When the universe is expanding, if the universe is expanding, that's the turnaround point where we should have the optical illusion of, hey, this is where, you know, the diameter of these galaxies should be. Now, if we look along the model, there's not a single galaxy in the predicted Big Bang when we're looking at angular diameter. Okay, this is a falsification of the expanding universe. Another falsification.
Can I wait before you do another
Okay.
falsification? So again, you know, I'm just seeing this for the first time, this thing, but if I understand it correctly, the red dots are what we're seeing with the James Webb
Yes.
Telescope and some of these other ones, and the other things are what you would expect with these models of galaxy formation. All right, and I would just point out again, what if these aren't galaxies? Now, again, this is just the world according to Nathan. This is just me thinking about this. So if I look at a mountain and then I zoom in, zoom in, zoom in, zoom in, zoom in, right? You know, fractally, I arrive at something that might look like what the macroscopic looks like. Okay, so this is like a fractal. And this happens in nature all the time. Um, and so if we say, okay, these things look like galaxies, the physical structures of galaxies, it is still possible that you're actually looking at something 10 times smaller and it resembles what is a magnitude greater. Um, and that's just what happens in physical reality. So,
Okay.
you know, I'm not saying that these red dots are galaxies. I'm saying they could be galaxies and we don't understand, or they could be active galactic centers with around growing huge supermassive black holes.
Okay. Here's a chart made by Eric Lerner that, and you know, I don't know if there's anyone out there saying that, Nathan, or if this is just the world according to Nathan. Okay. So I don't know
Yeah,
how
it
to
could be.
respond to that because, as far as I understand,
That doesn't make
all of
sense.
the literature right now doesn't make sense. I have no idea. Okay. Yeah, I never considered that possibility, and I have no idea if it's even remotely feasible or not. Like, you know what I mean? And I don't hear anyone saying that. I hear people repeatedly confirming in the literature that these are galaxies. So they're dealing with the problem as if these are galaxies. So your proposal is, I mean, it might be a good one, but I have no way of telling that right now. So, but this was done by Eric Lerner, showing 4 impossible galaxies. And what does he mean by impossible? Okay, he means there is a minimum radius, okay, where it's like too small. Why? Because the mass is too much the um for the size, and so it would collapse in. Okay, so this
Into a
is,
black hole.
well, and like I said, okay, maybe you need to talk
Okay.
to Eric Lerner. Okay, maybe you need to hash
All
out
right.
your idea with him and see if he thinks your hypothesis is a good one. But it doesn't matter, because this is, I'm coming against the Big Bang, and whatever this is, it doesn't fit with the Big Bang model. Okay, so but basically
To me,
this
it's
is
actually it's totally different. I mean, I think
okay.
what you're dealing with is the way that galaxies form. The Big Bang is before that, you know. So
Okay, well,
anyway,
there's so many problems with the Big Bang. Okay, it's a fantasy world, but We can talk. I did, it was too much to bite off more than, one problem at a time. But the red dots here, okay, are like the minimum radius for the mass that you can have. Okay, now the blue dots are showing the expansion calculation radiuses of these four galaxies, the radius and it's showing it's in the impossible range. Okay, this is not possible according to physics. Now, if we just take off the expansion calculation, if we just treat this as if this is a non-expanding universe, and we take the information that we're getting about these galaxies and we don't add any calculations to factor in for expansion, these are all in the green. Okay, these are all regular galaxies, totally normal density. So the problem is the expansion calculations. Okay, so, and this is just more if anybody needed on that. Okay, another contradiction of the expansion model regarding these distant galaxies is that the surface brightness test, okay, with the expanding universe model, we should not see the okay, if there's no expansion, then when we look out, we should see galaxies less and less bright according to their mass and diameter and all of that, right? Because they're farther away, so they should be less light getting to us. Okay. Now, if we don't factor in for expansion, then the galaxies that are at far distances match in perfectly with what we would expect when we look out and we see galaxies farther and farther away. When we calculate for expansion, then that's when we get these ridiculously bright surface things. So these galaxies with the ridiculously bright surface brightness. So all of the problems, not with the galaxy formation, but with the galaxy size, density, brightness, it's all because of the expansion calculations. Okay.
Okay,
So
but let me just take a step here. So what you're saying is, the furthest we can see, there's something we don't understand. Therefore, everything between um, means that there's no expansion. The problem you run into is that there are intermediate steps to that unknown. And if we look at something that we do know pretty well, which is, type 1A or whatever they're called, supernova, that have a certain luminosity and certain whatever, you know, it, if you can go out a certain distance and you see that, oh, there is a redshift there, that seems to indicate the universe is expanding. I mean, this is what the DESI project, I think, is dark energy. They're trying to map extremely well how the universe is expanding, and they're using starlight, I think, for that. So it you have an intermediate step that's a problem with your model, which is, if we look out, maybe if we go 13 billion, maybe there's these problems occur that you're talking about. But what if we go out 2 billion? What if we go out 3 billion? Like, if we're going out that far and we see that there's this gradient of expansion at those distances, then we need to approach the unknown from what is known, and you
but
or
we're
you have
not.
to account for what is known with your theory,
Okay.
or with your hypothesis, I should say. And
And
what is known is that it appears that these things closer to us are accelerating away.
what's causing you to say they're accelerating away? What's the evidence?
Well, so if I take a standard candle, right, and I put it at different distances, and I see that it is more redshifted the further it goes out. That's what the ladder model is.
Nathan,
So
but
so
but
whatever you're
and
saying about that, whatever you're saying about 13 billion years away, I'm saying it about 5 billion years away. I'm saying it about 4 billion years away. You see what I mean?
Um, by the way, we have a comment here. How are there galaxies that are older than the universe, Nathan? Okay.
Well, I don't think that there are galaxies older than the universe.
Well,
But maybe there
actually,
are.
what I
Maybe, like I said, maybe there's
think
something weird going on, and these galaxies are actually from another reality. I don't know.
okay, well, what I think what he means by that is that we're seeing them supposedly 250 million years, okay, after the Big Bang, but there's stars and things in those galaxies that take longer than that, according to star evolution, to form. So that would put them prior
That,
to.
that question is actually for a young Earth creationist. How
No,
are there
it is not.
galaxies older than the universe that you're saying?
No, it is
How,
not.
how is there light that's older than the universe you're saying? How are we looking 13 billion years away at
Because
these galaxies that didn't exist? If how are they so old if the universe is so young? If it's 10,000 years old, how is everything? I mean, we
Nathan,
still
you're
haven't even
going on a
answered
different
when I was
topic.
using parallax.
You're going on a different topic, but this is what, let
Well,
me get
that's a
back.
question. How
No, I know I'm
okay,
going
go
to
ahead.
right now because since you
All right.
brought up the ladder and the redshift, okay, look, Hubble figured out that the redshift and the supernova, he's the one who calculated it out first, okay? And he's the one who realized that there was a correlation between redshift and distance, okay? Redshift amount and distance, okay? Now, he actually didn't like the expanding universe model. Okay. He thought the redshift was something else. Okay. And he proposed that it may be
Yes.
due to something that's happening to light. Okay. And that's still on the table. Okay. There is some evidence that redshift is not caused, actually, expanding universe is only one of the many interpretations that you can take of redshift. Redshift could mean simple velocity, no expansion of the universe. It could mean everything is actually moving away from us. And that would put us at the center of the universe, which is what Hubble called a horrid, idea. He wanted to get rid of that idea. Okay. But his proposal that he liked the best, he thought something was happening to the light to cause it to be redshifted. And that's still something that's on the table that other people are proposing. So you have to understand expansion is one interpretation of the redshift, but it does not have to be interpreted that way.
Okay. Well, let's leave it at that. Should we move on to next
The next thing,
next
yeah,
the
because
next thing? Or no,
what
not the
I'm
next thing in
proposing,
PowerPoint, but our next topic.
wait, no, because I wanted to do one last thing, okay? Because I just want to say, okay, let me just make
Death by
one final,
slide. Okay.
okay, let me just show one final slide, okay?
Okay.
Because this is another comparison that Eric Lerner did of a galaxy observed at high redshift. Now, with the Big Bang calculations, the expansion calculations, this radius is ridiculously small. Okay. But if you take off the expansion calculations, in every way, this is like a normal sized galaxy. Okay. With the Big Bang expansion calculations, it's an insanely bright galaxy. It's you know insanely small. So the point is, the all we have to do to make these galaxies normal is just stop with the expanding universe nonsense. Okay, the expanding universe is what's causing these galaxies to be nonsensical. So if we just remove it, so that's removing a thing, like removing a parameter, like simplifying, and it solves a lot of problems. It solves the surface brightness problem. with the Tolman surface brightness test. It solves the angular diameter problem. It solves everything related to the size and density of these galaxies to just remove the expansion calculations. It also solves the dark energy problem. We don't have to have this made up thing of dark energy anymore if we just don't have the expansion calculations and we just take the supernova as if they're, we're seeing them as they are at the distance they are, and we don't mess with them and do all the expansion stuff. So do you see how this idea of expansion is actually messing up a lot of stuff and causing us to build more parameters, more invisible entities?
Well, I think what we're coming to here is that if you don't like expansion, then what would be good to do is to find all of the evidence for expansion, all of the latest data, and then build your own model. Like maybe this guy Eric Lerner will.
Yes,
Maybe it
he
will be a
has
steady
already.
state model. Okay, that incorporates as much information as possible, and what would be great is some sort of testable um hypothesis that, oh, if this is true, then X.
He's
And
already been
that
doing it for
X.
years. That's what I'm
Okay,
showing
well,
you.
well, great.
Published on it. He's published his results. He published his predictions. He published his predictions before the Hubble telescope when the Hubble wasn't supposed to see any galaxies either. Okay. His predictions came back correct. The Hubble, the
Okay,
JWST
this
wasn't
guy.
supposed to. So
I
what I'm
mean,
saying is
I'm
he's
like
already.
I said, I'm open. If this, if he found that the universe was actually steady state and he could get rid of dark energy and explain all the phenomena scientists have found, I actually don't have any problem with that. I think, okay, that's interesting. But I think that there is a lot of evidence for the Big Bang. Like I said, cosmic background radiation. You would still have to explain that. You would still have to explain why things are redshifted. Um, and and I don't think that light dying is a good answer. And I don't think dust is a good answer because those things have been ruled out. If you say light's dying or getting redder as it travels
Not
not
dying. I didn't
from
say dying.
expansion, then you have a lot of problems. No, I'm saying if you've got to come up with another explanation for why things are redshifted.
Well,
So
there are there
if
Nathan, there's a bunch of different hypotheses for why redshift exists. It could be light passing through plasma as it goes through the universe and
no,
getting distorted that way.
no,
Why?
they people have done uh they've done intense studies trying to figure out how much dust and everything the light is passing through. So you can't just say, oh, there's extra plasma, there's extra dust in the universe or whatever, because they've tested those things. So
Nathan,
you have to come up with an explanation for why light is redshifted. And expansion of the universe is the only thing left that they've come up with. If Eric Lerner comes up with another reason why it's redshifted, and there's not all this data that it's already excluded that parameter space, then fine, go for it. Build your model.
hold on. There's a comment here. Morgan Shady Buyer says gravity is at the location of ice nucleation. Okay. I do not understand this comment. So, do you understand this comment?
Gravity is at location of ice nucleation coordinates pi on circumference of a sphere in the dark, cold void of space created expanding universe and electromagnetic evaporated ice absorb.
Okay, I don't think it
Um,
makes any sense. But okay, so Nathan says, okay, I mean Hillary's email says Nathan, red shifting can also be explained via front scattering, not only Doppler effect. Okay. Do you know
well,
anything about that?
if he's talking about uh, I guess I need to look up exactly what front scattering is, but there are reasons why light could look red, right? Or become redder going through dust. I don't know if that's what front scattering is or whatever. But I do think that scientists have looked into a lot of these things because they did not want um, an increasingly rapid expansion of the universe. It did not fit their models, and so they were. they were looking for all of these things, you know. There might be new ideas. Maybe this front scattering is one that hasn't been explored. I don't know, but I do think that scientists have been looking for ways to get rid of the redshift at different points of time. And what they've arrived at is there's this energy or whatever it is that we can't explain, and they're trying to explain.
Okay. Well, let's put up your topic for next week.
Nothing.
Whoops.
So- oh, there we go. There we go. Loaded.
Okay, there you go.
All right. So, you know, last week, Rebecca really did some body blows on me. I think she exploited, she exploited my lack of preparation, and I feel bad because, um, maybe I wasn't prepared. You know, kudos to Rebecca. Sorry to our fans that I've let down. So, but I decided, you know what? It's time to hit the road. It's time to go on the offense, no more poking holes in science. Let's go to the source, of this strange idea, young earth creationism. And um, you know, but as Rebecca has been talking to me about Noah's flood, the thing that kept coming up in my mind is heat. Heat. Like, oh, these continents just suddenly split and moved halfway around the world in 1 year. And I just thought, what about all the waste heat from all of that? Um, and so I thought, okay, well, I'll just look it up. And, it might surprise you, or maybe it doesn't surprise you. I actually don't know that much about creationism. And maybe Becca is hoping that I'll go and investigate. So I did. I just looked, and sure enough, yeah, there's a video right there, very easy to find about heat. And the one I was watching this video, and I'll give the person credit when we do it. Um, but the one that I really loved was limestone hardening, and it's an exothermic process. Limestone hardening, solidifying, is an exothermic process that releases heat. And so if all of this limestone in the geologic column, or a broad swath of it, let's say, is from Noah's flood, and you laid down that much limestone, how much heat would be generated? That's going to be our topic for next week. And how do young Earth creationists account for all of that heat? And I've got another picture at the top there, and the thing that a thermonuclear explosion and limestone have in common is heat. So we'll see just how much heat this limestone would create in 1 year if it was all generated in 1 year of Noah's flood.
Cool. Sounds like an interesting topic. Now, I don't know anything about that. So if I have any young earthy friends out there that want to come next week and put your comments in the chat, that would be much appreciated, because I'm not allowed to study this week, not allowed to prepare. So I'm hoping somebody out there will prepare for me, and I can put your comments up on the screen. So Nathan, thank you for a good conversation. Thanks everybody for watching. Appreciate all of those who tuned in, and I hope it was beneficial. So we didn't ask who won. We didn't say who won. Does anybody, audience, who won this debate? Which side did you come out saying, I think that Rebekah had the better points? Nathan was just making up stuff that nobody did. Anyway, so let's see. Okay, let's see if anybody puts it in the chat. And anyway, yeah, it was a good conversation. But really, Nathan, did you come away thinking that you did I crack your confidence in the Big Bang at all?
Um, well, like I said, I ascribe to the Big Bang because it's the scientific it's the predominant model of Big Bang cosmology, cosmology. But I have my own, like I said, cockamamie theory about us actually existing in a topology, that I call a white hole, but it's basically a topological space in a much bigger region, where we're essentially a hologram of a, not a black hole, but a what I would think is happening with, you know, a different. So I won't go into all of this. We don't
Okay.
need to go into.
Yeah,
But
yeah, yeah,
anyway,
yeah.
I'm
But
open.
it's
I'm open.
interesting.
I'm open to weird ideas. I'm
Okay,
really open to
but
weird
it's funny
ideas. So
because I actually did see an article come out this week that said JWST gives us evidence that we are in a black hole.
yeah,
So
because
it's
one of the
really
things that you didn't mention is that most galaxies rotate in a certain direction. They spin in a certain direction, and that is really strange. That most galaxies would all spin in the same direction. And so that might be an indicator that there's an aspect of space time around us and around the universe that the universe we exist in, that we do not understand. So it might be pointing to something else. Another thing that's interesting is, I saw an article where they're looking at novas happening on either side of a jet of a black hole that's spitting out electromagnetic radiation. And on one side, there are more novas happening than on the other, which is something that's really weird. So I do think that it is possible that this guy Eric Lerner or other people are onto something that, so I'm actually open to the Big Bang being overturned. I just don't think the answer, even if it is going to be the universe is only 10,000 years old.
yeah, well, I am curious about that, Nathan, because it's so weird when I hear you talking about this because it's like, where is God for you? When you talk about galaxies all spinning in a certain direction, I'm like, okay, yeah, look, everywhere we look, it looks like there's a ready-made universe, and like, isn't when is it okay for just the answer to be God made it that way? Like, when would that be okay for you?
Well, I think if the evidence points to the Earth or the universe being older than 10,000 years, then it's okay for me to say that God created it 20,000 years ago. It's okay for me to say God created it, le- 13 billion years ago. I was talking to a person who's an atheist and a communist who comes and stays at our house sometimes. And I was saying to her, look, I don't really care if people believe in young earth creationism. It might be better for them in terms of their life. And she challenged me on that, you know. And then I thought about it, and when I watch Interstellar, and they're the dominant theory in the schools is that the moon landing is faked and stuff. I don't, it's like, oh, well, I don't believe that would ever happen. And yet, nowadays, with all this stuff on the internet, you think, I don't know, we need to educate people. And so I do think that there is information out there, and I think we should take it all in, and we should, try and listen to scientists and experts and delve into these things and come up with a worldview. And for me, um, I don't see, before the 1960s, young earth creationism wasn't really a thing even in Christianity. Maybe we can talk about that a little bit next week, but it's actually kind of a modern phenomenon. And so
Well, maybe the label young earth creationist is new, but the idea that God created recently is quite old. So, but we did have Hillary's email said that I won hands down. Thank you. Uh Michael says tie because of Stan's idea that they might not be galaxies in this brightness. Okay, I don't know.
Ty, okay, he's saying
Okay,
Ty
tie. Okay.
because of I guess Stan, he's saying the scientist guy you kept mentioning.
Okay, now I let me put up these because Hillary's email said Nathan should have argued white hole holography. I would have agreed with him. And Nathan should
Oh,
do a
I
stream on these alternative hypotheses. I'd watch. And he says Nathan is a good missionary for the Church of Materialism.
great. Not something I want.
Nathan, it
Well,
is weird though. I have to tell you that it's
well,
quite
when I
weird.
So when I was talking to the same communist atheists, what I said is, how do you account for math? Because even if you believe in Big Bang and you think the universe is billions of years old, even you know mathematicians um, cannot arrive logically at integers when you think about the philosophy of math. And yet, and there's always a push against some sort of Platonism, that math exists somewhere. But it is very hard to account for math. And if you cannot account for math, you cannot account for science. Really, you can't, because all of our physical sciences are based on math. So if pi doesn't exist somewhere, why is that ratio exist? What is it? And why is this construct that we seem to have come up with, math, why is it so good at explaining the physical universe? It it, it to me, there's still a mystery there. And it's not a mystery that's easily solved, even if you have a good physical theory of the universe. So maybe I am a missionary for the Church of Materialism. I don't think so. But I'm kind of forced to be this because I do not believe in young Earth creationism. I think that
Well,
the
and
evidence
there
does not
are
point to
other
it.
views. You didn't, but you mentioned all these scientists, and we listen to the scientists, but it really depends on which scientists are you listening to, because
I
there
don't
are
believe that.
there are good young Earth creation scientists. Okay, there are good
I think that there
scientists.
are young Earth creationist scientists who are experts in science fields, and they have PhDs. I do not argue against that. I think they do have, and they probably have created science that's in journals in their field of expertise. I think that young Earth creationism, uh, when they're trying to overturn these models and stuff, I do not believe it's scientific at all, and I think I'm going to demonstrate that next week when I destroy you with limestone.
Whoa!
So,
Whoa! Hey, well, then if you are able to, Nathan, it might be one of like 2 weeks where you actually beat me, because when I go down the list and I look at all the shows we've done, I'm like, beat him there, beat him there, beat him there. I'm like,
well,
and by the
I'm
way,
always on the defense. I'm trying to defend a model, right? You're trying to attack a model.
let me tell
I'm
you
going to
what
just go ahead and attack your model. I
let
don't
me
think you've
tell
actually.
you
Have you
let me
actually
tell you
learned all of the young Earth creation craziness? I mean, I won't call it craziness. That's not nice.
no,
But
but what you're defending is three anti-scientific religious myths. Okay, anti-scientific. Today, I gave you good evidence that contradicts the Big Bang model. I can give you a lot more. These are scientific observations that contradict the model. Okay, how many scientific observations have to contradict the model before we realize that's not a good scientific model? It has failed most of the predictions it's ever made. Okay, so it's been contradicted over and over and over again. What you're believing in, you think it's science, but what you're actually believing in is anti scientific. All of our observations about life originating, all of our observations show life does not originate by chemical processes. So if you believe life originated by chemical processes, you're believing something that goes against our scientific observations. Okay. Same thing.
obviously, we disagree about that. But I don't. The other problem I have is a problem of what I can know, right? And so there's a gigantic body of knowledge out there, which is accelerating. The growth of the scientific knowledge is also an expanding quantity of information. And it's kind of like the universe. And I cannot know all of that. As one human being, I cannot know all of that. And so I am going to have to trust other people. Now, who do you trust? Well, I trust because because it makes sense to me and because I read about it and I see that people are actively working on it, generating data. There is a coherent story based on physical evidence and empiricism. And um, I have to reconcile that with my faith. I went through a brief period where, I was trying to be an old earth creationist, and it just it just wasn't satisfactory. And young earth creation is even less satisfactory. So, it creates a more complex faith to have to try and hold these ideas together. It's true. And that's why I say maybe it's better for some people just to believe young earth creationism and go through life, because I do think they'll probably live a better life. But as a person who is interested in empiricism and science, I can't be one of those people. So there you go.
Okay. Well, I think where you're mistaken is about the science. So that's why I think it's good for us to have
Well,
these.
that's what this is about.
I know.
Yeah.
And so like I said, I have a lot more. I feel like I've hardly scratched the surface in the problems with evolution, all the problems that are faced by your models. And so, you know, yeah,
Okay. Well, well,
we've
next
got a
week
long way to go.
we'll bore people with exothermic limestone reactions, but the end is gonna come. It's gonna come away with a big bang. So we'll see how it goes.
Okay. Have a good night. Thank you. Bye, everybody.
But